All right, explain why each function is not a polynomial function. I'm just going to circle. This can't have a negative exponent. Let's see, this one has a fractional exponent. This one has x in a denominator, so that's not allowed. There's some other things that you also can't have. You can't have a square root of x. You can't have an absolute value of x. You can't have x in an exponent itself. For each polynomial, answer the following questions. Write it in standard form. So that is rearranging. So now you'd have f of x is 2x squared plus 8x minus 1. So the constant goes last, and you go from highest to lowest exponents. The degree is this 2 right here, the highest exponent. The leading coefficient, so this is the degree, this is the leading coefficient. They happen to be the same number. There are 1, 2, 3 terms altogether. The constant term is -1. F of 2 means take 2 and plug it into the function. 8 times 2 plus 2 times 2 squared minus 1. So 16 plus 2 times 4, so 16 plus 8 is 24. Minus 1 looks like it would be 23. Let's see. Put it in standard form. G of x is x plus 5. The degree is x to the first power, so 1. The leading coefficient is the number in front, so that's also 1. There are 2 terms in this problem. It has a constant term of 5, and if I plug in 2, 5 plus 2 would give me the number 7. All right, standard form. H of x, 3x to the 5th minus 6x plus 10. The degree, therefore, is 5. The leading coefficient is positive 3. There are 3 terms. The constant term is 10. If I plug in the number 2, let's see, 3 times 2 to the 5th minus 6 times 2 is 12 plus 10. Let's see. Oops. 3 times 2 to the 5th minus 12 plus 10 looks like positive 94. Use the polynomials. Okay, so I have to add, subtract, and add. Okay, so f plus g. I hope that I had you multiply. Oh, good. I have you multiply on the back. So let's see. I'm going to write my answers down and then talk about them. All right, so I grabbed the f of x function from up here, and I grabbed the g of x function from up here. So here's my original problem. The 2x squared would go in the front in standard form. I have an 8x and a 1x, so that gives me 9x. And then a -1 and a 5 would give me this positive 4. So this is my final answer for 3A. On 3B, I had to take f of x and subtract the entire h of x from up here. So my first step was to distribute this negative sign, -10 plus 6x minus 3x to the 5th. Then I brought my -3x to the 5th to the front. This 2x squared doesn't have any like terms. 8x plus 6x is 14x. -1 minus 10 is -11. So here's my final answer for 3B. And then I tried something different on 3C. I actually grabbed h of x, and then f of x I put below its like terms, and g of x I put below its like terms. Then I put it in standard form. 3x to the 5th goes here. 2x squared goes here. I have a total of 9 minus 6 x's, so 3x. And then 10 plus 5 is 15 minus 1 is 14. So there's my final answer, adding them together. The graph of the polynomial function has these factors. What are its 2x intercepts? So you need to set your factors equal to 0. So if x plus 8 is equal to 0, x needs to be -8 to make that true. So even though I could do that one in my head, this one you might not be able to do in your head. So your first step would be subtract 1 to the other side. and then you would need to divide by 2. So your final answer would be -8 and -1/2. Okay, the graph of the polynomial function is given. What are the x-intercepts? So I can grab that right from the graph. It looks like -3. This is not an x-intercept. It's a y-intercept. +2 and +5. So now I need to take the x-intercepts and make them into factors. So remember, your factors are opposite so that when you plug it in, you get 0. So x plus 3, x minus 2, x minus 5 are my factors. What is special about the 0 at x equals 2? It's bouncing off the graph, so it must have even multiplicity at that point. So that's going to change what's going on at this x minus 2. So I'm going to write out my final answer. Maybe it's x plus 3, x minus 2 squared, x minus 5. So let's see how close we got by putting it into our graphing calculator in the y equals menu. So parentheses, x plus 3, x minus 2 squared. Oops. And x minus 5. And I'm just going to put it in standard zoom. So it looks like our shape is similar, but we must have some kind of scale factor here, making it not quite as steep. Maybe it has a 1/2 or a 1/8 in front of it, but we got pretty close with our factors and our multiplicity. And that's how far you'd have to go on the final, is just something like this. All right, a polynomial function has these zeros, which could be the polynomial. This has 1 at 2 and 1 at -1, but it does not have any x-intercept at 0. So it is not A. This one has 1 at 0, 1 at -2, and 1 at +1. So those are opposite, wrong. This one has a 0, a 2, and a -1. So it must be choice C. All right, so I'm going to set up the box method for number 7 and then show you my steps. I think most of us know how to set up the box method for FOIL. I got 3x times x is 3x squared, -6x is -6x. This would be 21x and -42. And then don't forget to combine your like terms. I have 15x. So that's my final trinomial. Here is my 2x3 box. So let's multiply it out together. So I would have 3x cubed here, and then 3 times 3, so 9x squared, 3 times 5, 15x. Next row, 2x squared, 2 times 3 is 6x, 2 times 5 is 10. So if you notice, you kind of have like terms along your diagonals here. So you have 3x cubed plus 11x squared plus 21x plus 10. Let's see, how can I figure out if something is a factor? Well, I could try factoring this, but I could also try doing the division method that we learned with the box. So you put your divisor or factor that you think down the outside, and you're trying to get x squared inside when you multiply. So that tells you x needs to go on top in your quotient. X times -2 is -2x, and I need to add something to it to get to +7x. So I would have to add +9x in this circle. That means I need to put a +9 on top so that 9 times x is 9x. That gives me -18 in this bottom box, which is not -15. It has to work out perfectly, and it did not. It would have a remainder. Don't worry about getting a remainder for the final. But if you wanted to, your remainder would be a +3, because -18 plus 3 is how I get to -15. So not a factor, because my remainder is not 0. All right, so let's divide this. So x minus 2, and I'm going to put x cubed in this box. So x squared, negative 2x squared. I'm trying to get to positive 4x squared, so I need 6 of them here to get me to positive 4. Plus 6x goes here. Then I would have a negative 12x in this spot. I'm trying to get 0 x's in the original problem, so I need positive 12 x's in this spot. So I need a plus 12, a negative 24. So this is not divisible. To get to negative 7, I would have to what? Add, is it 17? Let's see. What is 24 minus 7? So 17. So if I add 17, I have a remainder of 17. Don't worry about the remainder, but I'll mostly ask you if something is a factor. Use technology to find all the points of intersection. So in your y equals menu, you're going to put in x squared times x plus 1 into your y1, and you're going to put x plus 1 into your y2, and you're going to see where they intersect each other. You might be able to just tell on the graph. So it looks like they have 2 intersection points, one here and one here. And so we're going to go to second calculate intersect, number 5. And I'm just going to arrow over. So I'm on the blue curve, the red curve, and I'm close to that intersection point. So it looks like up here they intersect. At 1, 2, they intersect. Oops. 1, 2. And it looks like they intersect down here. Let me see again. Second, calculate intersect. So I'm going to go right to that spot. Curve 1, curve 2, intersection point. So I'm not sure why my graph is not showing me the intersection point, but you can see on the graph they intersect here at negative 1, 0. And I couldn't show you when it was intersecting, but if I go to my table of values, I can see that at negative 1, both functions have a y value of 0. So my other intersection point that I can see on the graph is at negative 1, 0.